Okay, let's take a look at some more applications of systems of linear equations. So we're looking at mixture applications for our first two types of problems, and then we'll move on to distance problems. So we're on page 649 in your workbook. So in this particular case, we've got cashews, which cost $22 per kilogram, and Brazil nuts that are going to be mixed in, costing $16 per kilo, and the mixture weighs 50 kilos. That's a whole lot of cashews and Brazil nuts, and it sells for $18 per kilogram. So how many kilos of each type of nut were then used in the mixture? So we can do a couple of things for labeling. So of course, always we're going to remembering your steps. So your first step is always to label your variables very clearly. So not just C is equal to cashews, but C is the number of kilograms of cashews. So label, followed by writing out your two equations, and then solving the equations, solving that system for both variables, and then checking using the context and writing a statement. So in this particular scenario, we could use a table that some people find helpful, or we can just go ahead and label. So I'll show you both, and you can decide which makes more sense for you. So if we were not to use the table, we could simply say then that C is the mass of cashews. Okay, and so that's in kilograms for our units, and obviously then B is going to be the mass of Brazil nuts, also in kilograms. Okay, and so with that, we know that the total mass, so the mass of the Brazil nuts plus the mass of the cashews, is going to equal to 50 kilograms in total. Similarly, then, if we have another second equation that's going to be based on the cost of each, so the number of Brazil nuts, the kilograms of Brazil nuts, B times $16 per kilo, so 16 times B, plus the cost for cashew, which is $22 per kilo, and we've got C kilos of cashew nuts, is going to equal a sum total. Our total cost is going to be $18 per kilo. Well, how many kilos do we have would be B plus C, but easier than B plus C is actually 50. So that's that total weight then. So we've got our two equations and our two unknowns that we can solve for at that point. So alternatively, we could also label using a table. So we could have then Brazil nuts and cashews and the mixture, and then we can split that up into mass in kilograms, and then also the cost for those. So Brazil nuts, the mass of Brazil nuts was going to be B. For cashews, it was going to be C. So our mixture was going to be B plus C, which was also equal to 50. So we could write B plus C, or we could write 50, but that right there sets us up for writing our equation right here. So B plus C is going to equal 50. Similarly, Brazil nuts, the cost is going to be $16 per kilo, so 16B. Cashews was 22 times C, and so the total is then 18 times 50. And so then that is our second equation. So obviously you still need to write it out horizontally as we have on the side, but it's just another way to label those variables. So you decide what makes most sense to you. Okay, so now again we've got our two equations. We can either solve using substitution or using elimination, and that would be your call on what to do. And so I think in this particular case, I'm going to actually do elimination. So I'm going to multiply equation 1 by 16, or negative 16. So let me just change a color right here. So I'm going to take this and I'm going to multiply it by negative 16. So equation 1 times negative 16, so I've got negative 16b, and I'm going to write that right below equation 2, minus 16c is equal to, and 16 times 50 is going to be 800. And then we can go ahead and add. I know that 18 times 50 is actually 900, and so let's go through this. So if we add, then I end up with 0 B's and 6 C's is equal to 900 plus 800, which is 1,700. Whoops, nope, sorry, I needed to make that negative. So that's 900. Added that to 800, so that should be 100. Sorry. And then divide by 6 on both sides, and so then C is equal to 50 over 3 if we reduce. Or in this particular case, in the context of things, it probably makes sense to actually write that as a mixed number even. So 3 goes into 50 16 times, 16 and 2/3 to be exact. And so then if we want to figure out how many Brazil nuts we have, or the mass of our Brazil nuts, we'll substitute that into equation 1, or since we know 50 is our total, we can then say 50 minus 16 and 2/3 will give us B. So that is then 33 and 1/3 kilograms. So again, to check things out, what we're going to do is we are going to make sure that our total mass is 50 kilograms. So 16 and 2/3 plus 33 and 1/3 is 50 kilograms. So that first check works. So I'll just write that. So our check. So 16 and 2/3 plus 33 and 1/3 is equal to 50 kilograms. Our second check is to check that cost piece. So if I've got 33 and 1/3, 33 and 1/3 kilograms of Brazil nuts, and they cost me $16 per kilogram. So then we'll do $16 per kilogram times 33 and 1/3. And so I can use my calculator to go through that. Then 16 times, and we'll make that 100. Whoops. And so then that is 533 and 1/3. Technically that's in dollars. And so then we've got 16 and 2/3 kilos of cashews, and they are $22 a piece. So let's multiply that out, 16 and 2/3. So I'll use the calculator again and look at 50/3. So 50 times 22 divided by 3. That gives me 366 and 2/3 dollars. And if we add up that total, then that is in fact $900. in total. So averaging $18 per kilo, and we've got a total of 50 kilos. So in answer to the question, how many kilos of each type of nut were used, then we can say there are 16 2/3 kilograms of cashews and 33 1/3 kilograms of Brazil nuts. Great. Okay, let's take a look at our next question. So similarly, and this is what happens in those chemistry labs when we are having to make particular solutions. So when you're purchasing these types of chemicals from chemical supplies company, they don't have every single mixture available. So oftentimes we're having to mix our own to create the right kind of solution that we're looking for our experiment. So Earl the chemist has to make 180 milliliters of 60% hydrochloric acid. He has available 1 liter bottle of 45% hydrochloric acid and 1 liter bottle of 70% hydrochloric acid solution. So how many milliliters of each then are needed to make 60% hydrochloric acid solution? So again, this is one of those ones that you can put together just go ahead and label, or you can also use a table as well. So key thing is, so we're looking at making a total volume of 180 milliliters, and the other one has to do with the actual strength of it. So let's take a look. So we've got our two solutions. So we've got the 45% solution and the 70% solution. So let's take a look. So if we call A, we'll say A is the amount of the 45% solution, and that amount being in milliliters, and B is going to be the amount of the 70% solution, also in milliliters. So what do we know is we want to make a total of 180 milliliters. So that tells us our first equation, which is A plus B. So the amount of the 45% solution plus the amount of the 70% solution, and that should then equal a total of 180 milliliters. So that's our very first equation, and I don't need the units on that, but I do know that we've got milliliters plus milliliters equaling a total amount of milliliters. So the units are consistent, and so that it makes sense. Our second equation then is having to do with the actual strength. So we've got 45%, so 0.45 of A plus 70% or 0.7 of B, and that has to equal 60% or 0.6 of A plus B, but A plus B is obviously also 180. So we can just say, rather than 0.6 times A plus B, we'll just make it 0.6 times 180. Then, and I'll just clean that up by actually writing out what that is. So 0.6 times 180 is then 108 milliliters, essentially. So let's take a look then. So we've got our two equations, A plus B equals 180, and 0.45A plus 0.7B is equal to 108. So again, we can use either substitution or elimination in this particular case. I'm probably going to go for elimination again. So we're going to take equation 1, and perhaps I'll multiply everything by 0.45 then, or negative 0.45. So I'm going to take this and multiply it by negative 0.45. So 1 times negative 0.45, so that gives me negative 0.45a minus 0.45b is equal to, and then 0.45 times 180 is 81, or negative 81. And then we're going to go ahead and add those together. So the a's eliminate, and then 0.7 plus negative 0.45b, that is 0.25b, and that equals 18 and 27. Then we will divide both sides by 0.25, and b should give me then for 108, I believe. Let's just check that out. And it is, so B is 108 milliliters of a 70% solution. And then that means that A is going to be 180 minus 108, since we need a total of 180 milliliters. So that tells us that we have 72 milliliters of the first 45% solution. So let's again check that out. So our check then is, we have 72 milliliters of A and 108 milliliters of B, and total is 180 milliliters. That's a check, so that's the very first one. Second thing, do I have my 60% solution? So let's take a look. If I take 0.45, so 45% of A, which is 0.45 of 72, and that would give me 32.4. And then we take 70% of 108, and that gives us 75.6. And then if we add those together, we end up with 0, carry the 1, 108 milliliters, which is 0.6 times 180. So then that works out as well. So how many milliliters of each solution then is 72 milliliters of the 45% solution, and 108 milliliters of the 70% solution. And there's your answer. Great. Okay, looking at the next page, we've got some distance problems, and with these distance problems, I would strongly suggest that you use a table to go through these ones. So if you take a look, we've got a student who drives 1,245 kilometers from Edmonton to Vancouver in 16 and a half hours, including a 1-hour stop in Golden, 30-minute stop in Kamloops, averaging 100 kilometers per hour on the divided highways, 75 kilometers per hour on the non-divided mountainous roads. So how much time did she spend on the divided highways? So essentially we've got this split up into 2 different segments, and that would mean that we've got the divided highways as well, and the non-divided highways. And we are looking at distance, speed, and time. So with these, we just want to double check and make sure that our units are all clear. So distance, everything is in kilometers. Our speed, everything should be in kilometers per hour. And time, everything should be in hours. So at the end of the day, usually when we've got these tables, one column should explicitly be given to you, and in this particular case that is going to be our speed. So we've got 100 kilometers per hour on the divided highway and then 75 kilometers per hour on the non-divided highway. Okay, the next thing that we're looking at is actually our variables. So we've got the student driving a total of 1,245 kilometers. Since we're actually looking at time, so we've got a couple of different things that we can do. Because we're looking at time, we know that we can split that up. So time on the divided highway, maybe we'll call that D. The non-divided highway, perhaps we'll call that N. And what do we know is the total time was 16.5 hours, including a 1-hour stop in Golden, 30-minute stop in Kamloops. So really our total driving time though is then 16.5 minus the 1.5 hours. So our total driving time is actually 15 hours. When we look at our distance, well, speed times time is distance, so we can now fill in that third column. So again, our first column is explicitly given to us, so those are our speeds. Our second column is where we're going to label our variables, and then our third column is where we're going to use a formula where speed times time equals distance. So 100 times D is the distance traveled on the divided highway, and 75 times N is the distance traveled on the non-divided highway, and we know the total distance there is 1,245, and there we have our two equations right there. So we know that N plus D equals 15. So that has to do with time. Our other equation having to do with distance then is 75N plus 100D is equal to 1,245. So once again, we can take a look at either doing elimination or substitution. I'm going to go with elimination. Again, you can tell I certainly favor that. So I'm going to take equation 1 and I'm going to multiply everything by, let's go with 100 or negative 100. Then, so if we have that, we've got negative 100N minus 100D is equal to negative 1,500. That's an easy one for me since I don't have, I'm going to try to do this one without my calculator here. So now if we add these together, I've got negative 25N is then equal to negative 255, I believe. And so then we can go ahead and divide. Whoops. Okay, and so if negative 25N is equal to negative 255, then dividing both sides by negative 25, then N is equal to 10 1/5, I think. 255 divided by 25. So, yep, 10.2. Okay, or 10 1/5. Either way you look at it. So, 10 hours, 1/5 of an hour is 12 minutes. Right? And so if N is 10.2, we know that we've been driving for a total of 15 hours. So then that tells us the time on the divided highways is going to be 15 minus 10.2, which is then 4.8. So we've got 4.8 hours, or 4 4/5 hours on the divided highways, and 10.2 on the non-divided highways. And the total time was 15 hours plus the 1.5 hours of stopping time, giving the total trip time 16.5 hours. So then we can write our statement. So how much time did she spend on the divided highways? She spent 4.8 hours on divided highways. Sorry, if you wanted to do a quick check, I should have done that as well. So we checked the 15-hour total, but let's take a look. So if she was driving for 4.8 hours at 100 kilometers per hour, so 4.8 times 100 kilometers per hour is then going to give us 480 kilometers. That's on the divided highways. And then on the non-divided highways, so then we would have 75 kilometers per hour at 10.2 hours. And so 10.2 times 75 kilometers per hour is then 765 kilometers. That was traveled on non-divided highways. And if we total that up, then we can see our total distance is the total of 1,245 kilometers between Edmonton and Vancouver. So that checks out. Great. Let's take a look at the next question. So we've got a cruise boat, and this question is what we call a current question. There's also similar questions where you're looking at a wind as well. So what you want to consider is if you were in still air, so I'm just going to write something on the side here. So if we are in still air or still water, then our speed might be S. If you have a tailwind, or perhaps you're going downstream in a river with a current, then if you imagine, if you stop paddling, or if you're in the air and you're in a glider, what is your speed going to be? It's going to be the speed of the air, it's going to be the speed of the water. So essentially it just feels like you've got this little extra push. So what we're looking at then is it's going to be your regular speed plus the speed of the wind, or plus the speed of the current, versus if you have a headwind or you're going upstream, then if you imagine, if you turn your canoe or your boat around and you're facing upstream, if you stop paddling, you're essentially going backwards. If you're paddling upstream and you're paddling the same speed as the current, you feel like you're working, but you're not actually making up any distance whatsoever. So you actually have to think about your net speed. So your speed that you're going to be actually traveling is going to be your speed minus the speed of the current, or minus the speed of the wind. And so that's kind of how we need to label then, is we have to have our speed in still air or still water, and then our current or our wind speed that we are either adding if we are going downstream or with a tailwind, or we are subtracting if we're going into the wind or going upstream. So let's take a look. This is again really handy to use a table. So we've got a cruise boat who takes 3 hours to travel 36 kilometers downriver with the current. On the return trip, 4 hours against the current. So we're looking for the speed of the current and the speed of the cruise boat in still water. So we've got upstream as well as downstream. once again, you'll see me labeling for distance in kilometers, speed in kilometers per hour, and we also have time in hours. So we know explicitly it takes us 3 hours to travel downstream 36 kilometers with the current. So that means it is our speed of the boat plus the speed of the current. And on the way home, on the way back, it takes 4 hours, and we are obviously going to travel the same distance going back upstream, which is 36, but our speed is going to be our speed in still water minus the speed of the current, because that's going to be our net speed. So once again, we know that in order to find the distance traveled, we multiply the speed that you're traveling times the time. So speed times time is equal to distance, right? Distance is equal to speed times time. So that means that 4 times s minus c equals 36 is our equation 1, and 3 times s plus c is equal to 36 is equation 2. So let's expand both of those, or alternatively, we can simplify it. Let's say if I was to divide equation 1, it's kind of handy because 36 is divisible by 4. So if I was to divide both sides by 4, then I would actually have s minus c is equal to 9. So that's a new and improved number 1 in smaller numbers. Same thing with equation 2, because 3 goes into 36. Conveniently, we can divide left side and right side by 3. So then s plus c is equal to 12. And that's a nice equation 2. And look at that, we're set up perfectly for elimination. So if we go ahead and add those together, then we have 2s is equal to 21. So s is then equal to 10.5. And s is, of course, our speed in still water. And then what do we know is I can substitute that into any of my equations if I choose, let's say, 1a. So in 1a, then we know that 10.5 minus c is equal to 9. So then c is equal to 1.5. So that is the speed of my current. And so it's not a very strong current by any means, but my cruise boat is actually not moving all that fast either. And that makes sense. If it's taking me an actual 4 hours to go 36 kilometers, then I'm not traveling that fast. I've essentially got a net speed of 9 kilometers per hour as well. So that makes sense. So it says find the speed of the current and the speed of the cruise boat in still water. So here we go. Speed of boat is 10.5 kilometers per hour, and the speed of the current is 1.5 kilometers per hour. So some tricky questions for today, but if you have questions, please ask, and definitely do some practice. Consider what labeling works well for you. Definitely consider using a table. Ensure that you have units regardless of what you do, and check your work using the context of the question. Thank you.